नमस्कार दोस्तों। लास्ट क्लास में हमने एक पैरेलल कॉम्बिनेशन का इक्विवेलेंट रेजिस्टेंस का फॉर्मूला पढ़ा था, जिसका फॉर्मूला था 1/R इक्विवेलेंट इक्वल्स टू 1/R1 प्लस R2 प्लस R3. It is calculated only for the three parallel resistance. If there are more than three parallel resistance, then the general formula is that 1/R equivalent equals to 1/R1 plus 1/R2 plus 1/R3 plus up to 1/Rn, where n can be 2 or more than 2. Okay, now we are calculating the formula. Now we are solving a question to understand the use of this formula. Okay, so we are solving the question. Question is find the equivalent resistance between the point A and B, where three resistance are connected in the parallel, that is R1, R2 and R3. The value of R1 equals to 6 ohm, value of R2 is 3 ohm, value of R3 is 4 ohm. Now we calculate the equivalent resistance. When we are moving from point A to point B, then there are three paths to travel from point A to point B. One path go through the R1, second part is go through the R2, and the last part is go through the R3. If we are having more than one path to travel from point A to point B, then it is known as the parallel combination. Okay, now we solve this question. First we write down the given values. What is the given? That is R1 equals to 6 ohm, R2 equals to 3 ohm and R3 equals to 4 ohm. We know that in a parallel combination, in a parallel combination, equivalent resistance is, what is the formula of equivalent resistance? That is 1/R equivalent equals to 1/R1 plus 1/R2 plus 1/R3. Here is the only three resistance, R1, R2 and R3. That's why we are write down up to R3. If there are four resistance, then we also write down the R4. If there are more than four resistance, or there is about 7 resistance, we write down till R7. Okay, now we put the value of R1, R2 and R3. That is 1/6 plus 1/3 plus 1/4. Okay, now we take the LCM, that is 12. It is a simple calculation. Sometimes students write down that is R equivalent equals to 9/10, but this is not the value of R equivalent. This is the value of 1/R equivalent. Okay, so first, must we care about to this R equivalent equals to 12/9, that is 4/3, or we can say that is 1.33 ohm. Okay, it is the value of equivalent resistance between the point A and point B. Okay students, now we are solving the another question where we are saw that equivalent resistance can be termed as the another named, or it is the value. Sometimes in question that is not given, it is not given that it is a parallel combination. It can be termed as the another named. is find the maximum resistance or find the minimum resistance. Now we are solving the question based on the minimum resistance. To solve that question, if it is given that find the minimum resistance, you must be have knowledge that if question is asking about the minimum resistance, then it is told about the parallel combination, because in the series combination we are adding the resistance, so the value of resistance is increasing. So in a series combination we get the maximum or highest resistance of the combinations, and if we are talking about the parallel combination we get the minimum value of resistance or lowest value of resistance in a parallel combination. Okay, now we are solving the question based on that. In this question given that find the highest and the lowest resistance. Find the highest and lowest resistance from combination of resistance of 2 ohm, 3 ohm and 4 ohm. What is the given? That there are three resistance, that is 2 ohm, 3 ohm and 4 ohm. We calculate the highest and lowest resistance that is made from the combination of resistance. Okay, now we solving the question. First we calculate the highest resistance. I am already told about that if we want to calculate the highest resistance by the combination of different resistance, then highest resistance only can be get by the series combination. To get the highest resistance, the resistance must be connected in the series combination. Highest resistance can be get by series combination. Series combination means these three resistance 2 ohm, 3 ohm and 4 ohm are connected in the series. Okay, now we draw the circuit diagram, that is three resistance are connected in the series. It's a point A, it is a point B. Okay, it is a 2 ohm, 3 ohm and 4 ohm. Now what is the equivalent resistance? That is R equivalent equals to, what is the formula of series combination? That is R1 plus R2 plus R3. Now we put the value of R1, R2 and R3, that is 2 plus 3 plus 4, that is a 9 ohm. So highest resistance is 9 ohm. It is the highest resistance because it is obtained from the series combination. It is the highest resistance that can be made by the combination of these three resistance. Okay, now we are talking about the lowest resistance that can be get by the parallel combination. Get by the parallel combination. Okay, now you draw the diagram. Parallel combination में okay, there's a point A, point B. This is 2 ohm, 3 ohm and 4 ohm. Okay, now we calculate the equivalent resistance between point A and point B. That is 1 upon R equivalent equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3, where value of R1, R2 and R3 is 2, 3 and 4. R equivalent equals to 1 upon 2 plus 1 upon 3 plus 1 upon 4. Now we are solving the LCM is 12, that is 6 plus 4 plus 3. Okay, 1 upon R equivalent equals to 13 by 12. It is the value of 1 upon R equivalent. So we calculate the R equivalent equals to 12 upon 13 ohm. Okay, you can see that initially when we connected in the series combination, then we get the value of equivalent resistance, that is 9 ohm, and now we get the value of 12 by 13. So which one is the larger? 9 ohm is the larger value than the 12 by 13. So we can say that if resistance are connected in the series combination, then we get the highest resistance by combination of such resistance, and if they are connected in the parallel combination, then we get the lowest resistance. Okay, now we move on to the next question. It is a question that having the series combination and the parallel combination both. Okay, now we solve that question. Question is, this is the question: find the equivalent resistance between point A and point B. Now this is the diagram where point A is here and point B is here. When we move from point A to point B, there are two parts to move from point A to point B. First path, that is through the 3 ohm, and second path, that is through the 1 ohm and 2 ohm. One path is directly and second path is like this. Okay, to calculate the equivalent resistance, first we calculate that it is a direct path, so there is nothing to calculate. But from point A to B, there is another path. In that, 1 ohm and 2 ohm are connected in the series combination. So first we solve that. First we solve that 1 ohm and 2 ohm resistance are connected in the series. Connected in the series. So the equivalent resistance equals to R1 plus R2. In series combination, what is the formula of equivalent resistance? That is R1 plus R2 plus Rn, but here is only two resistance, 1 ohm and 2 ohm. So we are using the formula R equivalent equals to R1 plus R2. Value of R equivalent equals to 1 ohm plus 2 ohm. So R equivalent equals to 3 ohm. Now we can redraw the diagram. Now 1 ohm and 2 ohm can be replaced by the 3 ohm. Okay, 1 ohm and 2 ohm can be replaced by the 3 ohm because it is the equivalent resistance. Means 1 ohm and 2 ohm are having the same effect on the circuit, that is the value having 3 ohm. Okay, so we redraw the diagram. Point A, point B, 3 ohm, it is 3 ohm. Okay, now we are having the two paths to move from point A to point B. One having a 3 ohm resistance and another is also having a 3 ohm resistance. But if we are having two paths, then it is a parallel combination. Now we calculate the equivalent resistance between point A and B, where 3 ohm and another 3 ohm resistance both are in parallel combination. Now we are applying the formula of parallel combination. Both resistance between A and B are parallel. in parallel combination. Formula is, what is the formula of parallel combination? 1 upon R equivalent equals to 1 upon R1 plus 1 upon R2. Here is only 2 resistance, so we are using up to R2. So 1 upon R equivalent equals to, what is the value of R1? That is a 3 ohm. What is the value of R2? That is a 3 ohm. Okay, 1 upon R equivalent equals to 3, 1 plus 1, that is a 2. 1 upon R equivalent equals to 2 upon 3. It's a value of 1 upon R equivalent. So R equivalent equals to 3 by 2, that is, sorry, it is a 1.5. 1.5 ohm. Okay, so maybe you understand that sometimes there are series and parallel, both combinations are present in the circuit. So first we solve the question in such manner that we get the answer as soon as possible and in a easiest way. Okay, here 1 ohm and 2 ohm both are in series combination and 3 ohm are in parallel combination. So first we solve that 1 ohm and 2 ohm are in series combination to get the equivalent resistance, that is a 3 ohm. Now we replace 1 ohm and 3 ohm by the 3 ohm. 1 ohm and 2 ohm by the 3 ohm. Now 3 ohm and another 3 ohm equivalent resistance is in parallel combination. So we can solve it is by easiest method, that is 1 upon R equivalent equals to 1 upon R1 plus 1 upon R2. Now we put the value of R1 and R2. Now we get the answer, that is 1.5 ohm. Okay, this is the another way, and this is the way to solve this such type of questions. Now we are having another question that is also based on the series and parallel combination. Question is, find the equivalent resistance between the point A and point B. Now it's a quite bigger question in size, but it's a very simplest question of it. Okay, in this question, when we move from point A to point B, now first we are getting a 3 path. What we are getting? We are getting a 3 path. If we are having more than one path, it's a parallel combination. Okay, so 3 ohm and another 3 ohm are in parallel combination. First we solve this 3 ohm, 3 ohm, 3 ohm combinations, parallel combination. Okay, then when we come at here, then we are getting 2 ohm. It's a single path, so it's a series combination. After that, again further we are getting the 6 ohm, 6 ohm and 6 ohm resistance, means we are having a more than one path, so it is a parallel combination. Okay, so first we saw this parallel combination and this parallel combination. Okay, then we get the simplest way to solve this question. Okay, now this solution. Now we solve this parallel combination. This is a parallel combination, that is 1 upon R equivalent equals to, here 3 ohm, 3 ohm and 3 ohm are in parallel combination. So parallel combination formula, that is 1 upon R equivalent equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. We are having R1, R2 and R3. Okay, it is R4, it is R5, R6 and R7. Okay, what is the value of R1, R2 and R3? That is a 3 ohm, 3 ohm and 3 ohm. So 1 upon R equivalent equals to 1 upon 3 plus 1 upon 3 plus 1 upon 3. So 1 upon R equivalent equals to 3 ohm is the, 3 ohm is the LCM, 1 plus 1 plus 1. 1 upon R equivalent equals to 3 upon 3. It is a value of 1 upon R equivalent. So R equivalent equals to 3 upon 3, that is 1 ohm. It is 1 ohm. And it is also parallel combination, R5, R6 and R7. R7 are in parallel combination. Are in parallel combination. Okay, so now we calculating the equivalent resistance, that is 1 upon R equivalent R2. Okay, 1 upon R5 plus 1 upon R6 plus 1 upon R7. 1 upon R equivalent 1 upon 6 plus 1 upon 6 plus 1 upon 6. 1 upon R equivalent 2, that is 6 is the LCM, 1 plus 1 plus 1. So 1 upon R equivalent 2, that is 3 upon 6. So R equivalent 2 equals to 6 upon 3, that is 2 ohm. Okay. Now we are having the equivalent resistance of this circuit and equivalent resistance of this circuit. Now we put the value and redraw the diagram. Now the circuit is converted. Now the circuit is converted in such phenomena, that is in such way, that is it is a simplest way. It is a first equivalent resistance, that is 1 ohm. Here is R4, that is a 2 ohm, and is the another equivalent resistance, that is 2 ohm. Now R 1 ohm, 2 ohm and another 2 ohm are in series combination. 1 ohm, 2 ohm and 1 ohm, 2 ohm and 2 ohm are in series combination. So the equivalent resistance what is the formula of equivalent resistance in series combination? That is R1 plus R2 plus R3. यहाँ पे R equivalent 1 plus R equivalent 2. It is R equivalent 1. It is R equivalent 2. Okay. What is the value of R equivalent 1? That is a 1. What is the value of R4? That is 2. What is the value of R equivalent 2? That is 2. So 1 plus 2 plus 2. So value is 5. So the equivalent resistance is 5 ohm. Okay. Hope you get the way to solve series parallel combination. Now there are some questions to solve you. In next class we are discussing about that questions. Questions are following. These are the 3 questions that will solve by you. You try. If you are not able to solve, then I will help you. Okay students, so today class we are discussing about the questions based on the series parallel combination. Some questions are based on the series combination, some questions are based on the parallel combination, and in some questions both are present, series and parallel combination. Okay, it's your task that you will do these 3 questions. It's the simplest question, but there is a trick, there is a little bit tricky questions. Okay, you must be try. Okay students, we will continue the next topic of our chapter in the next class. Till then, stay home, stay safe.